Hello everyone, welcome to my session Bring DevOps to the Swiss Alps. My name is Wolfgang Ofner, I'm a freelance cloud and software architect based in Toronto, Canada, and I focus on cloud technologies and Kubernetes and DevOps. If you have any questions after the session, feel free to reach out on LinkedIn, Twitter or via my website. Today I want to tell you a project I was involved while I was living in Switzerland. The project was called Autonomous Ropeway System, and the idea of this project was to implement an intelligent ropeway system. Then I want to tell you about the challenges we faced during the project, how we used Azure Arc to integrate an on-premise Kubernetes cluster with the cloud, and what other features Azure Arc offers. If you want to get the slides, you can scan the QR code on the page, or you can also go to my GitHub. Before I get started, I want to show you what a ropeway system actually is. Here you can see a ropeway vehicle. This is used in Switzerland to transport people from a valley up a mountain. In Switzerland we have them almost everywhere, and in summer we use them for hiking, and in winter we use them for skiing. But they're also getting more and more popular in cities to get around. So the idea of the project Autonomous Ropeway System was that the whole ropeway system will become intelligent. This means, for example, the vehicles come automatically out of the garage if they are needed. And if they are not needed anymore, they go back into the garage. Currently it is that in the morning, some employees have to get them out of the garage, put them on the ropeway, and at the end of the day, put them back in the garage. The problem is that they have to estimate how many people will come on this day. If they put too many vehicles on the ropeway, they will use more energy, they will have wear and tear, and it's gonna be expensive. If they don't put enough vehicles on the ropeway, people have to wait and they might get angry and not come back. Another advantage of the intelligent system will be that the vehicles can do routing. Right now they go from point A to point B, for example, from the valley to a mountain. But with this intelligent system, it would be possible to find a way, especially through a city, for example, or you could say, I have one valley station that goes on two mountains, and I can decide on which mountain peak I want to go. As I said, if you use too many vehicles, it might be expensive, and if you only use what you need, it's better usage and also less wear and tear, and therefore it is cheaper. And the idea is to run 24/7 with the minimum human interaction, therefore also having a cheaper system, but also having a convenient system for the people that use it. As always, we were facing a couple challenges. The first challenge was that we had to use existing hardware. That was a requirement from our customer and nothing we could change. This also meant that we had to use something on-premise and not cloud only. And the second big challenge we were facing was that the firewall that was controlled by the customer didn't allow any inbound traffic. This means that we are using Azure DevOps for our deployments, but the problem is that Azure DevOps doesn't have any connection to the hardware since it's blocked by the firewall. The same with other cloud servers. For example, Azure Monitor is blocked, so we can't do monitoring. Then there's the question, how do we collect logs, metrics, everything we need for operations? And my first idea was we just create a VPN connection or an express route connection and everything will be fine. But this was also not allowed by the customer. Here you have a very simplified overview of the network. So on the left side, we had the existing hardware. It was Ubuntu 18.04 back then. And there we decided to install Kubernetes to manage all the software we were running. And in the middle, we have the big firewall that was not allowing traffic from outside inside the network. This means Azure DevOps couldn't do any deployments. Azure Monitor couldn't do any monitoring. The only thing that was allowed was from inside to the outside. This means the Kubernetes cluster could pull containers from Docker Hub or Azure Container Registry. This was working. And here you can see a couple pictures of a test station. So this was a station the customer built where we could test our software. For me, it was a highlight of the project because I'm usually working on software projects where there's no hardware involved. And this was the first time that when I did something in the software, a vehicle started moving. And it was quite cool, to be honest, that we could move them around. And here you have a picture how the whole system works. So if a customer comes, they can select here on this button box where they want to go, and then the display told them to which entrance they should go. For example, here on top, you can see that this ropeway vehicle is going to Alps, I think it is, and it's going to take 15 minutes, and there are 10 spaces left. You might know this system from airports or malls where you select outside the elevator where you want to go, and then the system tells you which elevator you should take, and there are no buttons inside the elevator. Okay, before we get started with the project, I want to introduce you to Azure Arc. Azure Arc allows you to manage your infrastructure that's running outside of Azure with Azure resources. This means it could be on-premise infrastructure, but also infrastructure that's running in Google Cloud or in AWS. You can manage Linux and Windows servers or VMs, any CNCF certified Kubernetes distribution, and also Microsoft SQL Server. And here an overview of all the services that are available. So it's also Azure Stack, HCI, VMware, Postgres, SQL. There's a whole bunch of services. And the idea is that you can project your infrastructure into Azure, and then you use the Azure Arc service to have a single pane of glass to manage all the infrastructure. So you don't have to learn any dashboard, you just have this one view, and then you can use Azure services to manage the infrastructure. For example, if I click on Kubernetes cluster, I can see that I have 2 Kubernetes clusters connected with Azure Arc at the moment, and I also get some basic information. For example, what's the name of the cluster, what version is running on, and so on. And as I said, you can manage your infrastructure with Azure. This means you can use the Azure services you already used to manage your Azure resources the same way on your on-premise infrastructure. For example, for VMs or server, you can use update management and configuration management, but you can also install tools, for example, the Microsoft Cloud Defender, and manage your on-premise VMs the same way as your Azure VMs. And you can also manage Kubernetes cluster. This whole process is called Azure Arc Enabled Kubernetes. And you can also add extensions to the Kubernetes cluster. And these extensions bring Azure functionality to your on-premise cluster. This could be Azure monitoring, GitOps for deployments. You can have an Azure Key Vault integration, and there are many, many more tools. For example, there's some for Azure Policies, Open Service Mesh, and many more. And another big advantage is that you can securely connect to your cluster, even though the firewall is blocking every incoming traffic. I'm gonna show you later how this works. But first talk about the project itself. I think I forgot to mention in the beginning that the project I was working on was a proof of concept. So I was there during the proof of concept stage. And since the proof of concept, we wanted to have results as fast as possible. Therefore, we decided to use K3s as our Kubernetes distribution. It's a lightweight open source Kubernetes. It's developed and maintained by Rancher. So There's a big community behind it, great documentation, and it's really easy to install. It's just this one curl command, and you have a Kubernetes cluster with one master node running. And it's just a single line command again to add more worker nodes to the cluster. So it took us only a couple minutes to get the Kubernetes cluster started. And next we installed Azure Arc. To be able to install Azure Arc, you need the Azure CLI and the Azure Arc CLI extension. Once you have installed the Azure CLI, you can use a single command again to install Azure Arc on your Kubernetes cluster. Since we are using K4S on-premise, I executed this command on the master node, and all you need is the Azure CLI command. Then you provide a name for the Azure Arc instance and in what resource group Azure Arc should be installed. This command is downloading a couple Helm charts and is installing the Azure Arc agent and a couple other applications inside your Kubernetes cluster. And after a couple minutes, you can check that the installation was successful. You can check in the Azure CLI, but also in the Azure portal. And all the applications of Azure Arc are installed in the Azure Arc namespace. So they're completely separated from everything that's running already in the cluster. And here you can see everything that's installed. I think it's 11 applications in total. And the names are quite good, so you can already figure out what they're doing. For example, you have here an extension manager. Then you have here for identity to authenticate. Then you have here something for metrics to collect metric information. And as I already said, Azure Arc is a single pane of glass. This means you have your Azure Arc instance in the Azure portal and you can manage it the same way as infrastructure that's running in Azure. So if you go back to our Azure Arc instance, and we see again the two Kubernetes clusters, and here on the bottom is the one we just installed. And if you click on this, you get this view in the Azure portal. And if you're using Azure Kubernetes Service, this will look very familiar. It's almost identical. So if you have used Azure Kubernetes Service before, it will be very easy to get used to Azure Arc. The big difference is if you click here on the left side on the Kubernetes resources, and if you use Azure Kubernetes Service, you see everything that's running inside the cluster. If you use Azure Arc, you have to first provide a token to authorize or at least to sign in this request. So before you can see what's going on in the cluster, we have to configure the access to the cluster. And this can be done by two ways. The first one is to use the Kubernetes RBAC system and create a token and then pass the token. Or the second one would be to use Azure RBAC and then generate the token. Using the Kubernetes approach is easier because you only have to create an account or a user and then generate the token. And if you use the Azure approach, you have to register the application in the Azure Active Directory, or now it's called Microsoft Entra, and then generate the token. For our proof of concept, we just wanted to check if it's working, and therefore we decided to use the Kubernetes approach. And what's also great is once you have this token, a developer can execute a command in the Azure CLI on their development machine and connect to the Kubernetes cluster through Azure Arc, even though the inbound connection is not allowed. And with this, the developers can use the kubectl, the Kubernetes CLI, to access the cluster and use all the tools they're used to work with a normal Kubernetes cluster. So to generate this token, we first have to create a new service account. This is done with the Kubernetes CLI kubectl, and the command for this is kubectl create service account, and then we provide a name. In this case, the user is called admin user. Then once we have this user, we have to add the roles this user should have. This again, done with kubectl, create cluster role binding in this case. Then we provide a name for the binding. Then what role this user should get. In this case, it's cluster admin. This means that the user can do almost everything in the cluster. And then what the service account name is. This is the same service account we've just created, admin user. And once this role binding is done, we can create the access token. That's done again, kubectl, and the command is create token, and then what's the name of the user we want to create the token for. And then the token is pasted into the console, and we can take this, copy it, and paste it in the Azure portal. And once we sign in, we see everything that's running inside the Kubernetes cluster. So now that we have access to the Kubernetes cluster, we want to bring more features to the cluster itself. And this is done with extensions. I want to show you 3 extensions we used. The first one is the GitOps extension to manage the deployments. Then Azure Monitor, as the name says, for monitoring. And then the Azure Key Vault extension for the Key Vault integration. So for the GitOps extension, this agent is using Flux. Flux is a popular open source GitOps tool, and this extension will install the agent inside the Kubernetes cluster. This agent can be installed via CLI or Azure Portal, and the great thing about GitOps is that the agent is connecting to a Git repository and is monitoring this repository for changes. If something changes in this repository, the agent is downloading the changes and applies them. And these files could be YAML files or Helm charts. And since the agent is running inside the Kubernetes cluster and checking an outside Git repository, this means we don't have any inbound connection. Therefore, the firewall won't block this deployment process. And it doesn't matter if you want to access a public Git repository, for example on GitHub, or a private one, such as Azure DevOps. I'm going to show you in a couple slides how to access an Azure DevOps repository. And as I already said, you don't have to have an inbound connection to do this deployment. This graphic shows how the GitOps process works. So on the left side, we have the application repository, and when a developer finished a feature, they hopefully create a pull request, and this pull request triggers a pipeline that can run unit tests, check for vulnerabilities, and so on. And once this pull request is merged with the master or main branch, this triggers the CI pipeline. The CI pipeline usually runs more tests and also creates a Docker image and pushes this image to a container registry. In our case, it was the Azure Container Registry, but you can use whatever registry you want. And after this pipeline is finished, you can trigger automatically the CD pipeline, or you can also do it manually. In our case, it was manually, since deploying is not straightforward because the Ropey system is transporting people, and therefore it needs many checks and also with the authorities. Therefore, it was manual in our case. But no matter how you trigger the CI pipeline, once the pipeline runs, it updates a second repository that's usually called the GitOps repository, and this repository contains all the configuration for the cluster. For example, the Helm chart, and it updates the version in the Helm chart. This is being done down here. And then inside the Kubernetes cluster, we have the Flux agent, and this Flux agent is monitoring the GitOps repository. And once the CD pipeline commits the changes to the repository, the Flux agent sees that, downloads the changes, and then deploys them to the Kubernetes cluster. And with this approach, we can do automated deployments without having any access to the Kubernetes cluster. So before I can create our deployment, we have to create a personal access token in Azure DevOps, because in Azure DevOps we're using private repositories and we have to have this token so the GitOps agent can access the repository. So here you can see the configuration of the token. On top, we just provide a name and then how long it should be valid. And all the permissions you have to give is the code read permission, nothing else, because the GitOps agent only has to read the repository and then download the changes. And once you click on create, you will see the access token, and it's important to copy this access token somewhere safe, because this is the only time you see the token. If you don't copy the token away, you have to create a new one. It's also the same process if you use GitHub. There you can also create an access token and use this token later. And with this, we can install the GitOps extension. I prefer using the Azure CLI because it's quite readable and easy to execute. And here you have the command. If you've never used Azure Arc, it will still be easy for you to figure out what's happening. So on top, we just have the Azure Arc command to create the Flux extension. Then we say, what's the name of the cluster? That's the K3S Arc cluster we've created before. In what resource group this cluster is, what is the name of the extension, in what namespace do we want to deploy it, then what's the cluster type. This one can vary if you use an on-premise Kubernetes cluster that's managed with Azure Arc, or if you're using Azure Kubernetes Service. In this case, connected cluster works for Azure Kubernetes Service, so you can just copy this command and execute it in case you want to try it yourself. Then we're going to provide a user and the previously generated access token, then the URL to our Git repository, on what branch the agent should monitor, and then the path to a customization file. I'm going to talk about it more later, what this file is and why we need it. And you can also see here on the bottom that the extension was not found and the Azure CLI is going to install it first. So the first time you create this command, it's going to take a couple minutes to install the extension. And once the extension is installed, it's going to install the agent. And after this command is done, you can see the agent in the Azure Arc instance in the Azure portal. Here you can see it's compliant, the deployment succeeded, so everything is working fine. But in case there's something going wrong, you can click here on this name and then you will get more information about what's going on. So we clicked on the name and there you can see, for example, what's the URL to the Git, what's the branch, and you will also see error messages in case something happened. And then you wait a couple minutes and the GitOps agent sees that there's a repository. This repository is different than what's currently running inside the Kubernetes cluster, downloads the Helm chart and installs it. And so we have our application running inside the Kubernetes cluster. So as I said, for the GitOps agent, we need a customize file. And this customize file is quite powerful, but I don't want to go into any details today. So for today, it's enough if you remember this file is referencing all the files that are needed for the deployment. And therefore, here you can see it's very simple. So we just use the kind customization, and then we reference all the resources we need for the deployment. In this case, it's a single YAML file with the name Helm release. And then we have a second YAML file in the repository. That's the Helm release we referenced before. And this YAML file is containing all the information about the Helm chart and for the deployment. So if you take a look at this file, you can see that the kind is also Helm release. Then we say in what namespace it should be deployed. We provide a release name and then the path to the Helm chart inside the GitOps repository. And this annotation here is only needed if you use an Azure Kubernetes service cluster. But I added this here so in case, again, if you want to try it yourself and just create a quick AKS cluster, you can just execute it. And to have automated deployments, we also have a GitOps or a CD pipeline. And this pipeline is also very simple. So once we start the pipeline, it's reading the newest tag from the Azure Container Registry. Then it replaces the tag in the values YAML file of the Helm chart. That's just a simple PowerShell search and replace. And then it commits the changes to the master branch. And since this created a new commit, the GitOps agent sees the changes, downloads them, and deploys them in the K3s cluster. So now we are done with the deployment, but there's so much more you need to operate an application inside a Kubernetes cluster. The first one is, how do we manage our secrets? If you're using Azure or Azure Kubernetes service, you have usually a managed identity. With this, you can authorize requests to the Azure Key Vault and read the key vault secrets from the Key Vault. The great approach about this is you don't need any passwords, nothing, it's just with the identity. Since we are running on-premise, we can't use this approach and we somehow have to authorize our requests to the Key Vault. And this is where we can use the Azure Key Vault extension. This extension allows to mount Azure Key Vault secrets as Kubernetes secrets and also as environment variables. These secrets are synchronized via gRPC, and this has the advantage that we can use everything that the Azure Key Vault offers, for example, password rotation, auditing, access control, and so on, and also use them on-premise. And then we also have another very simple pipeline, and this pipeline writes or updates secrets in the Key Vault. And with this approach, we always knew when we changed something in the Key Vault and what we changed. And another great thing about Kubernetes or this whole approach is that you can add this extension without having to change anything in your application or in Kubernetes itself. Kubernetes offers the secret store CSI provider, and there you just tell it to use Azure Key Vault instead of what's using it by default. Then the last extension I want to talk about is the Azure Monitor extension. Once you install this extension, it's installed in its own namespace, so it's completely separated from all the other application, and the Azure Monitor agent is collecting metric and log information and then sends them to an Azure Log Analytics workspace. And again, since the agent is running inside the Kubernetes cluster and sending information to the cloud, it's an outbound connection and the firewall won't block the messages. And once we have the messages or the information in Azure, we can use Azure Monitor to create dashboards, alerting, and also gain insights what's going on in the cluster. This means resource usage of the nodes, but also what's going on inside the containers. That's the same Azure Monitor as you would use if you're using Azure only. That's nothing separate. So once you know Azure Monitor, you will be good to go. And here you can see how this looks in the Azure portal. These are dashboards that are already pre-configured from Microsoft, so I didn't have to do anything, only install the Azure Monitor extension and it started sending information. And here you can also see that something was going on. At around 9:30, the CPU utilization of the node suddenly increased dramatically, and this triggered an alert because it reached the 80% CPU usage threshold, and the support team could react to this and figure out what the problem was and resolve the problem within a couple minutes. So at around 9:39, the problem was resolved and the CPU usage went back to maybe 5%. And the customer didn't even recognize that there was a problem going on. And to figure out what the problem was, they used the container insight view. And there you can see on the right side that this one container suddenly had a big spike in CPU usage. And with this, the support team could identify that it was the container named customer API, and then look into the logs of the customer API and figure out what the problem was. So that's everything I wanted to tell you today about how we managed the Kubernetes cluster with Azure Arc, but Azure Arc itself brings so many more tools, and they're called Azure Arc services. So first, we have the Azure Arc enabled infrastructure. That's what I already mentioned before. You can manage your infrastructure with Azure Arc. This could be servers, Kubernetes cluster, and also Azure Stack HCI. But then the interesting services are the so-called Azure Arc enabled services, and there you can run Azure services on your on-premise Kubernetes cluster. This means services like Azure SQL Managed Instance, Postgre, or machine learning. And this is the first time that you can run Azure services outside of Azure. I'm going to show you in a couple slides how we used Azure SQL Managed Instance to have the database running in our Kubernetes cluster. But there are also more services. So for the first time, you can run Azure App Services outside of Azure, or the Azure Logic Apps. And all this is done with Azure Arc. To be able to do this, you need an Azure Arc enabled Kubernetes cluster. This means you have to have a Kubernetes cluster running on premise, but also it could be in the Google Cloud, GCP, or with AWS. And then you can just install the Azure services you want to run. And the great thing is, for developers, it doesn't make any difference if it's running on-premise in your data center or if it's running on Azure. So they can just work the way they were used to with these services. And here a quick overview of the whole landscape of Azure Arc. So on the bottom, you have all the infrastructure. This could be Azure Stack, HCI, VMware, AWS, GCP, it doesn't matter. Any infrastructure outside of Azure. Then you install Azure Arc, and then you can manage the applications, the infrastructure inside Azure. And as I just said, you can also add Azure services to your on-premise infrastructure, like Azure Functions, Azure App Service, Logic Apps, and a whole bunch more. So lastly, I want to show you how to use Azure Managed SQL Instance in your on-premise cluster and why to use it. The first reason why to use it is it's managed by Azure or by Microsoft. This means you get all the advantages you have of running it in Azure. This means Microsoft takes care of installing the SQL Server in your Kubernetes cluster, to install updates, to create backups, to scale the database if needed, as long as you have resources in your on-premise cluster, obviously. And it also adds Kibana and Grafana, so you have out of the box a view into the matrix and the logs of the SQL Server. And here you can see the Kibana dashboard. that's coming all pre-configured out of the box. And you can see what's going on inside the SQL Server. And also a Grafana dashboard. There you can also see how many transactions do you have, what's the CPU percent usage. And since Grafana, you can always add or edit the dashboards as you need. This works again on any Kubernetes distribution or any hardware. You only have to have Azure Arc installed, and then the SQL service runs again in its own namespace. So as all the other services, it's completely separated from everything else in the cluster, and you can install it via Azure CLI or the Azure portal. It only takes a couple commands, so you have to set up the data connection. I'm gonna skip this for now, but once you have done this, it's just this one line command to create the database. So you provide a name, then in what namespace it should run, and with this dev flag, you say it should use a developer license and therefore you won't be even charged. Then you have to provide the username of the admin and a password. And then the database is being installed in your on-premise cluster. And the big advantage of using this, besides that everything is managed by Microsoft, is that your data will always stay within your data center. None of your data will be ever sent to Microsoft. And this is critical for some companies that handle customer data, maybe health data, and also with data protection becoming more and more strict, this can be a game changer for many companies. The only data that's sent to Microsoft or to Azure is some metadata information. For example, for how long were you running the database, how many CPU cores were you using, because that's how you get billed. So what's the conclusion of the whole project? In my opinion, the proof of concept was a major success. Everything was working as we expected. We had some troubles here and there, but I guess that's normal if you try out something new. Azure Arc is a really powerful service. I would even say it's the most powerful service Azure offers. And it's also a major focus of Microsoft. So there's no conference you could go and you don't hear about Azure Arc. It somehow feels it's everywhere. But there are also a couple downsides. For example, if you want to use this Azure Arc integration, you have to have a broad knowledge of how IT works. So you have to know a bit about firewall, networking, DNS, automated deployments, DevOps, Kubernetes. So it's not just 3 clicks and the service is running. Then what I've experienced is that the service can be buggy sometimes. Sometimes it takes a couple tries to install them, or sometimes you install them via the CLI and then you don't see it in the portal. It can be annoying, but nothing major so far. And also the documentation could use some improvement. Sometimes I felt like I read documentation, opened 10 different tabs and I still didn't know anything. So yeah, sometimes it can be hard to get started. But again, overall, I think it's an amazing tool and it's definitely worth checking out. So at the end, here at the QR code, you can scan it again for the slides. And I also included a couple resources. There's a playlist on YouTube, on my YouTube channel. There's the Azure Arc documentation and also an Azure Arc series I'm writing on my blog right now. So thanks for joining me, and I will see you at the Q&A session.